Okay, so we are in section B, and this section comprises of very short answer type questions, and every question is of 2 marks each. Okay, so the first one is we have to solve the pair of equations x is equal to 3 and y is equal to -4 graphically. So let's sketch its graph, and so let's say this is a plane with x and y axis. This is x axis, this is y. Now x is equal to 3 is a line which is parallel to y-axis. So this is x is equal to 3. Okay, x is equal to 3. And the next one is y is equal to -4. So -4, let's say it's -1, -2, -3, and -4. So this is the graph of y is equal to -4, which is parallel to x-axis. And now both these lines intersect at 3, 4. So this both of these lines are intersecting at 3 comma -4. So the solution of this graph is x is equal to 3 and y is equal to -4. Okay, for part B, we using the graphical method, we have to find whether the system of linear equations is consistent or not. And we have to plot the graph of x is equal to 0 and y is equal to -7. So let's plot the graph. So this is, let's say, x and y axis. Now x is equal to 0. So this is the origin x and y axis. So x is equal to 0 is here. And we know that when we plot the graph for x is equal to 3, it's a line parallel to y-axis. Now x is equal to 0, we have to plot a line parallel to y-axis at 0. So this is actually the y-axis. So x is equal to 0 is your y-axis. Now the y is equal to -7 is a line parallel to x-axis. So let's say it's -1, -2, -3, 4, 5, 6, and 7. So y is equal to -7 is a line parallel to x-axis. Let's say this is parallel to x-axis. So y is equal to -7. Now this is x is equal to 0 and this is y is equal to -7. Both of them are intersecting at -0 comma both of them the point of intersection are 0 comma -7. That is the point of y-axis, and x is y is equal to -7. Both are intersecting at 0 comma -7. So solution for this is, so is x is equal to 0 and y is equal to -7, and by graph there is a unique solution. So this is a unique solution. That means the given pair of equations are consistent. Okay, moving on to question number 22. For question number 22, we have to find the length of xy, and in the figure is given that xz is parallel to BC. So xz is parallel to BC. So we can say that in triangle ABC, xz is parallel to BC. We are doing question number 22. So xz is parallel to BC, therefore by using BPT theorem, we get ax upon xb is equal to az upon zc. Now az is given, which is 3, and zc is given, which is 2. So ax upon xb is equal to 3 by 2. So this is 3 and this is 2, and this whole length is 5. That is AB is equal to 5. So AB is equal to AX plus XB, which is 3 plus 2 is equal to 5. Actually, these are the in proportions, but if we take them as a multiple of some constant 3x and 2x, so this will cancel out and still we will get the same value 5x. Okay, now it's given that MC is 5 centimeter, the AZ is 3, ZC is 2, BM is 3, and we have to find the value of XY. So uh, now in this triangle, in triangle AXY, and let's say triangle is ABM. So in AXY and triangle ABM, angle A is equal to angle A. This angle is common. So this angle is common. And now, so angle A is equal to angle A is common, and angle AXY is equal to angle ABM because these are corresponding angles. So angle AXY is equal to angle ABM because these are corresponding angles. So AXY is equal to ABM, so that means the triangle AXY is similar to triangle ABM by a similarity. Okay, once these triangles are similar, so we can get the sides in proportion. So that means AX upon AB is equal to XY upon BM. Let's put in the values. So AX is 3 and AB is 5. XY, we have to find out XY. And next one is BM. So BM is given, it's 3. So BM is 3. So xy is equal to 3 into 3 divided by 5, which is equal to 9 by 5. And this is equal to, it's 5 over 5, 1.8. So this is 1.8 centimeter. Okay. So this is 1.8 centimeter. And let's move on to question number 23. So for question number 23, okay, it's given that sine theta plus cos theta is equal to 3 root 3, and we have to find the value of sine theta into cos theta. So it's given that sine theta plus cos theta is equal to root 3. Now squaring on both sides will give us sine theta into cos theta. So squaring on both sides is sine theta plus cos theta the whole square is equal to root 3 the whole square. So this gets cancelled, and this is now sine square theta plus cos square theta plus 2 sine theta into cos theta is equal to 3. Now sine square theta plus cos theta is 1. So this is 1 plus 2 sine theta into cos theta is equal to 3. So this is 2 sine theta into cos theta. 3 minus 1 is 2. 2 and 2 gets cancelled. So we are left with 1. So sine theta into cos theta is 1. 6. It did. It's the division that we did for 2 and 2. So it's 1. Okay, so next one is option B, where it's given that sine alpha is equal to 1 by root 2 and cot beta is equal to root 3. We have to find the value of cosecant alpha plus cosecant beta. So for part B, it's given sine alpha is equal to 1 by root. So sine alpha is 1 by root 2. That means cosecant alpha is root 2. Okay, now cot beta is root 3. So cot beta is root 3. And we know that 1 plus cot square beta will give us cosecant square beta. Let's put the value of cot beta, which is root 3 the whole square, is equal to cosecant square beta. So this is 1 plus 4 Okay, so this is 1. Sorry, 1 plus 3 is 4. So this is 4 is equal to cosecant square beta, and cosecant beta is equal to root of 4, which is equal to root 2. So if we have to add them, so cosecant alpha is root 2 and cosecant beta is 2. So answer is 2 plus 2. So cosecant alpha plus cosecant beta is equal to 2 plus 2. Okay, this solves our part B. Okay, for question number 24, we have to find the greatest number which divides 85 and 75, leaving remainder 1 and 2. So 1 and 2 has to be the remainder for 85 and 72. So let's subtract 1 from 85, which is 84, and subtracts 2 from 72, which is 70. This is question number 24. Now let's find the HCF of, so HCF of 84 and 70 we would have to find out so that we can get the greatest number which will divide 85, which will divide 84, but will remain leave remainder 1 in this case, which will divide 40, but for 72 it will leave remainder 2. So 84 is, if we factorize, this is 221 and 3 into 7. This is 2 square into 3 into 7. And 70 is divided by 2 is 35, and 7 5 are 35. This is 2 into 7 into 5. So this is 7 and above 10. So HCF is equal to 2 into 7. So between 2 square and 2. Smallest is 2 and common in 7 and 7 is 7. So HCF is 14. So 14 is the greatest number which divides 85 inside 2, giving remainder 1 and 2 in each case. 25th is an easy one. The bag contains 4 red, 3 blue, and 2 yellow balls. So total balls are 4 plus 3 plus 2, which is 9. Okay. So total balls in this case are 4 plus 3 plus 2 is equal to 9. And let's clear this. Okay, so we have to find the probability that drawn ball is red. So probability of red ball is equal to number of red balls are 4, total balls are 9, so this is 4 by 9. And we have to find the probability of the yellow, so yellow balls are 2 and total balls are 9, so this is the required probability. Let's move on to the next page. Okay, for the next page is section C.